Hi everyone, I'm Hashmita, a technical content creator at Block Quantum, and welcome to another Block tutorial. So today we are looking at one of the simplest way to bring quantum computing into machine learning, which is the quantum reservoir computing or the QRC. So imagine you're trying to predict tomorrow's electricity demand, stock price, or even sales for the next week. These are all time series forecasting problems where the goal is to predict the future using the past data. So normally training quantum machine learning models can be computationally expensive because the quantum circuit itself has to be optimized. So QRC takes a completely different approach. Instead of training the quantum circuit itself, the quantum circuit stays fixed here, and we call this fixed circuit the quantum reservoir. And here's the idea. So you take a small window of historical data and encode it into the quantum circuit. So as the qubits evolve, they naturally create a rich high-dimensional representation of that data. We then measure the qubits, and then those measurements, measurement results become features for a classical machine learning model. And now the best part is that only the classical model is trained. So the quantum circuit never changes. That means the training is much faster while still benefiting from the expressive power of the quantum system. And as of the enterprise users, QRC can improve forecasting across industries from supply chains and smart grids to finance and manufacturing. So this helps the organizations make much more informed data-driven decisions. On block, the workflow is very straightforward. You simply upload your time series dataset, choose a quantum reservoir computing module, configure a few parameters such as the number of qubits, the historical time window, the forecasting horizon, and then run the experiment. So block automatically handles the quantum encoding and then executes the reservoir circuit, extracts the quantum features, trains a final classical regression model, and then displays the forecast along with performance metrics. Now that we have understood the concept, let's switch over to block and see how we can build and run a QRC model in just a few clicks. So now we are on Block's platform, and for this demonstration, we'll be using the Maclear Glass time series data. So it is a benchmark data which is widely used in this reservoir computing research, and it consists of just a single numerical sequence generated by the Maclear Glass delay differential equations. So this exhibits complex and chaotic temporal dynamics. The objective is to predict the future values from the past observations. So this would make it an ideal dataset for evaluating the forecasting abilities of the QRC. Let's give start experiment now, and then the title to QRC, and it comes under forecasting. Select the QRC algorithm. The dataset has already been uploaded. Now setting the qubits to 2 and letting the rest stay default. And now when I run, so the results are out here. The quantum reservoir model has achieved a training ASCII score of 1.0, indicating that it has successfully learned the underlying patterns in the training data. And also, it has achieved a test ASCII score of 0.79 on the unseen data. This demonstrates a good predictive performance and generalization. So, the model then generated the forecast of the next three time steps, illustrating how the quantum reservoirs could be used for time series prediction without training the actual quantum circuit itself. So, thank you.